My name is Jim Coleman, and I lead DXC's data and analytics portfolio team. Myself and a few of my coworkers would like to take a few minutes and present some of the solution accelerators we have developed that give DXC a competitive advantage when helping our clients transform their data and analytic platform.
Hi, my name is Kal Kanev, and I'm the Director of the Global AI Practice at DXC Technology. Today I'll talk to you about machine learning operations and how our accelerator helps clients industrialize their AI initiatives. First of all, what is machine learning operations, or MLOps? It is the automation of the lifecycle management of machine learning systems. It is a software and business process framework which combines people, processes, and technology to ultimately support machine learning development, testing, and release, and leads up to phases such as maintenance and integration with enterprise applications. Constructing an industrial-grade MLOps platform is not an easy task. It involves a lot of best practices, many of which are specific to data science. For example, things like lineage and reproducibility of models, data versioning, robust monitoring, and mechanisms for fully automated handling of model deterioration are often overlooked. And why do we need MLOps? The simple answer is companies need to have an MLOps setup in order to operationalize their AI efforts. Statistically, only about 20% of AI initiatives show a significant ROI, and very few machine learning experiments make it into a new product or service. The companies that are able to do so are the ones that are successfully applying MLOps. DXC has an MLOps Quick Start which is fully approved by Microsoft and enables creation of an MLOps platform with a click of a button. It allows for ultimate flexibility for data scientists and ML engineers. It allows for creation of reusable ML pipelines. It capitalizes on CI/CD for machine learning, provides robust real-time model monitoring, and it introduces automatic no-ops model freshness by using event-based model retraining. The accelerator is backed up by an MLOps reference architecture, embedded best practices around processes and ways of working to industrialize machine learning efforts. At a high level, there are a few core components of the MLOps Quick Start which you see in our Azure workspace, covering experimentation, dev, test, and production environments. Namely, we have CI/CD pipelining for deployment. To minimize the manual effort, model pipeline deployment itself is performed with the help of Azure pipelines. Flexible experimentation setup for data scientists to perform experiments in their preferred environments and tools and frameworks. We basically leverage containerized notebooks and IDE environments that are versioned, shareable, and scalable. Feature storage at the same time is another important component. Through feature storage, we introduce a separation between data and MLOps architecturally. ML pipeline development allows for model training pipelines to be pushed to production and automatically train, test, and compare new model versions if necessary. Model repositories enable orchestrated and fully logged model training runs both in development and production. And lastly, model monitoring, which includes, number one, monitoring of the prediction service and the output of the model. Number two, monitoring of model performance if new labeled data arrives and requires evaluation of the current production model. Monitoring the involved data pipelines ensures the validation of the data quality in real time. The MLOps Quick Start Accelerator gives you speed and capabilities on Azure native services. Organizations can save on long development times in perfecting the automation of a comprehensive MLOps platform. As a result, models can be published to production over 25 times faster to help companies reach much higher profitability when using AI. Thank you very much for your time. We hope you enjoyed this brief presentation on the DXC MLOps Accelerator. Feel free to reach out if you have any questions.
Hi, this is Jim Coleman, and I'm going to do a quick walkthrough of our automated data migration framework. DXC's automated data migration framework is a set of DXC-developed pipelines and applications that migrate the contents of a source database to a target database. It is used by our database services teams to provide a competitive advantage in modernizing our clients' data storage infrastructure. There is no charge for the software. It is just an accelerator leveraged by the DXC team. The automated data migration framework delivers reduced cost and risk of the data migration by automating the process, which in turn reduces the time, effort, and errors common in manual data migration. So why automate the data migration? Our experience has shown that data is migrated many times during the development, testing, and production phases of a migration project. Automation reduces the effort, time, and errors, as well as minimizing disruption to your business when doing your production data migration. Having a data migration process you can trust means your business can move to a modern database platform quicker and then be able to take advantage of the many benefits a modern cloud-based environment provides. The automated data migration framework is a complete solution for your database, migrating the schemas, data, roles, users, and privileges. The migration tool can connect directly to the database over the network and extract the data, or we can provide scripts to the database administrators who then extract the database components to a delimited file and copy that to the target database system to be imported. If you have extensive database code to migrate, DXC can also automate the code conversion leveraging a third-party tool. The automated database migration framework supports several source and target databases and is built to easily add others. Having one tool that can migrate different types of source systems to a common target system simplifies the process. Here are a few example migration scenarios. The architecture for the automated data migration framework is straightforward. We install our pipelines and applications in the Azure environment. These are built using Azure native services. The migration is driven by a parameter file, one for each migration instance. The framework connects to the source database, extracts the components, performs any required conversions, and imports the components into the target database, logging any errors. When the migration is complete, the framework performs a cleanup and writes final details into the log. As part of the framework, DXC has developed generic tie-out reports which can validate the complete set of data was migrated and that the records match the originals. This extra step helps assure you will not find discrepancies in the data down the road. Now I would like to show you a quick walkthrough of the migration process. It starts with defining a parameter file to drive the migration. We have an example of a parameter file here. In this file, we define the database type, connection strings, login information, and options such as migrating all or a partial set of the schemas. Once the parameter file is set up, we can go into Azure DevOps and kick off the migration. Here you can see I navigate to the package that we want to run. We select Run the Pipeline, choose the source type of database we're running, and then we can go ahead and begin the database run. When the run kicks off, it will validate the infrastructure, validate the connections to the systems, and then begin the migration. The speed of migration will be driven by the amount of data, network bandwidth, and the speed of the source database system. This process can run unattended as all steps are logged for review. Okay, we let the migration run to its completion. You can see here that the process was completed. It's split into 3 separate sub-processes, creating the infrastructure, running the migration, and then running the security migration. The total migration took 20 minutes and 18 seconds to run. Once it's completed, you can go to the log file and you can check all steps are written to a log file, including any warnings or errors. You can also trace the creation of the schemas. You can see the tables are created here. We also show the creation of the roles, the users, and the granting of the privileges to the different roles. Once the migration is complete, you can also check our tie-out report. Here you see the tie-out report we ran during the migration process. You'll see not all the tables have been recreated, but now that it's complete, we can refresh the report. And here it shows us the list of all of the different tables and the record counts, and we sum the fields to make sure that they match as well. And we have a visual as well as a numerical representation of everything. If there's any variation, these green fields will go to red, but you're also able to see that the numbers tie out in counts, again, both numerically and visually. This concludes the overview of DXC's automated data migration tool.
Hello, my name is Srijani Dey, Chief Data and Analytics Officer at DXC. Today I'll talk about the data quality accelerator that we have developed as a part of our innovation team. The biggest challenge between IT and business units is accelerated adoption of data products and harmonized data or KPIs. This comes from the sheer issue of lack of trust of data due to quality issues and inability to trust the data and the KPIs that are being generated. So another bottleneck for adoption is the usage of the data and its ability to have a low latency validation on the data that business might need to build the insights, and then that could be a one-off validation, and that gets stuck in the circle of getting the service request created and then gets responded as per its own SLA. By then, the need of the data, by the time they get the validation done, the need of the data is gone. What you see here are the details of the bottlenecks, like between the design, every isolated way of approaching the solution. What happens is the isolation creates a bottleneck because the data warehouse thinks separately as the application thinks separately as to how to solve a data quality issue, but it is actually an end-to-end problem. Tools is another issue where hard coupling of the tools into the solution, no modularization or service orientation, reducing the applicability of the solution end to end. And then comes processes like governance and democratization with guardrails are the new norms, right? So people expect democratization. So even the process democratization of data quality is a need that people have. And none of the off-the-shelf tools are able to kind of cater to those needs. In order to avoid such bottlenecks, DXC have come up and created an audit balance and control framework that augments any other custom or a licensed product solution to create data with end-to-end visibility and democratize the tool with a UI-based front end and creation and capability of creating and validating data to eliminate the latency of operations team getting back with the requested validation or data. There are technical quality checks that you see on the left-hand side that are standard ABC checks, which look at the record consistency and integrity. These are embedded within the pipelines. There could be number of record check, null checks, default value checks, and others. But however, within the pipeline, they are microservices exposed through API endpoints. The second category is the checks for business checks, which are like on the right-hand side, what you see is about the ad hoc way of executing some checks on the data, which can be executed by a steward or operations team for spot checking data for an event or a particular one-off scenario. For this, we have built a self-service portal for data quality checks, which users can configure the checks, which generates an API endpoint and a microservice, and that can be invoked through an ADF pipeline to execute on a desired data set. The solution also entails a better data literacy and data fluency so that business have trust on the data products and then confidently able to articulate a data value chain and plug insights where the data is more pertinent. So we have taken a holistic approach. You see the first block, it is a process flow, defines where the data checks needs to be embedded. The second one is about upfront definition of success criteria, be it integrity, consistency, and we define the measurement criteria and the KPIs. The third one is about the key building blocks of the data quality, where we are able to put a holistic approach encompassing the profiling as well as a precursor. And after the quality checks are done, what is the next best action? The fourth one is the audit balance and control check, which is the end-to-end setup of what is being audited, what are being balanced against the data, and what is the action to be taken to be determined and which is determined by the control block of the algorithm. Also important is to identify the fifth block. What you'll see is what are the repeatable patterns and applicability of the checks across the pattern, which is why the solution is modular so that we can plug in multiple checks and same checks in multiple patterns and multiple checks in the same pattern. Then comes the last block, which is the data certification, where what we do is each check is associated with a weightage, which adds up to the certification of the data to be consumed. So essentially what we are looking at is the key building blocks are service-oriented democratized solution, are API-driven endpoints to be able to invoke anywhere in the end-to-end pipeline, fully metadata-driven solution which works on batch as well as streaming events, and the drill-through dashboarding to be able to look end-to-end visually and have the traceability of the data quality checks from the data pipeline. Let's quickly look at a demo where you will see how we have end-to-end configured this data quality checks. So what we first do is define the layers. So there could be the checks can be applied in any layer. As I was saying, it is modularized, so it can be applied on landing or harmonization, but there are different data sources for each of those layers that can connect to. Then we do a setup of the rule where what we do is we select a category, which I showed about in the building blocks of the solution. It could be conformity check, but then again within that could be range check, where you can have different criterias and parameters that define that range check. Format check, you will have different parameters again which can define it. And then what we do is we can do a configuration of the rule. So once you select a rule, you can then a particular layer, you choose it, and then you can add another rule to it so that these can be configured as and or, but these are predefined rules. So rules are already defined now with the microservice when we set up the rule. But now what we do here is associate the data structure and the columns on which the rules have to be executed. What you see at the end is the API endpoint that you see in here that can be plugged into an ADF and which will invoke the data quality check. And you do not need to go through any kind of IT support services. This can execute on your data once you have permission on your data. Thank you very much.
Thank you for watching the overview of some of the DXC data and analytics accelerators. If you would like further information, please reach out to us at dxc.com/MicrosoftPractice, or you may email us at microsoftpractice@dxc.com.